In today's video, we're going to start looking at some right angle trigonometry, and this is where we start looking at our trigonometric functions, so sine, cosine and tangent and their reciprocals. And we're going to be sticking with these functions for the rest of the course, but we'll introduce them today. So let's say that we have this right triangle here. Okay, it has three sides, A, B and C. And between the sides A and B, we have this right angle being 90 degrees. Okay, any right angle is always 90 degrees. If you wanted to put it in radians, you can say it's pi over 2. But whenever we talk about triangles, we tend to keep it in terms of degrees. And later we'll introduce the radians with sine, cosine and tangent. But right now we're going to look at it as though it is 90 degrees. And then we have this unknown angle theta. It's an acute angle, meaning it's less than 90 degrees. We know that. And what we want to do is to find sine, cosine and tangent in terms of these three sides, A, B and C. First thing I want to talk about before we go into that is the Pythagorean theorem, or you'll just hear it talked about as Pythagoras, which tells us that for a right triangle, so any triangle that has that right angle 90 degrees in it, that this should hold true. A squared plus B squared equals C squared. That tells me that the two sides that are next to that right angle, if I square them and add them together, it should equal that what we call hypotenuse. I'll write that term down. Okay, it's this side here, that diagonal side that is opposite that right angle. A squared plus B squared should equal C squared. Okay, so if you are ever given a problem where they ask you for sine, cosine, tangent of an angle, etc., but you don't have all three sides, first thing I want you to do is make sure that you get all three sides, and you may have to do that by using Pythagoras, by using this Pythagorean theorem, by manipulating this equation a squared plus b squared equals c squared to find the unknown side. So bear that in mind. Whenever you've got a right triangle, you can always go ahead and use that formula in order to find an unknown side. Now I want to introduce the three main trigonometric functions: sine, cosine and tangent. We tend to just write them as the first three letters in those terms, so sin, cos and tan, but they stand for sine, cosine and tangent of an angle theta. Okay, that angle theta can be anything, but right now we are going to look at it in terms of this right triangle. And the question is, how do we find out sine, cosine and tangent? Okay, they're just functions of an angle, okay, just like f of x, okay, is a function of x. This is a function of the angle theta. And these particular trig functions are incredibly useful as we go throughout this course. We will see them used time and time again. But the question is, how do we find them for a particular right angle triangle like we have here? There is a rhyme, or this particular set of letters that we put together, and different people call it different things. This is the way that I've always been taught to remember it, is SOHCAHTOA. Okay, SOHCAHTOA. Okay, if you remember that, you can always remember how to find sine, cosine and tangent of an angle theta by looking at a right triangle. To find sine of the angle, we're going to do the side opposite it divided by the hypotenuse. So it's the opposite side divided by the hypotenuse. So if we go back to our right triangle here, the side that is opposite our angle theta would be the side A. And the hypotenuse is C. So to find sine of the angle, I just do A divided by C. Cosine of the angle, again going back to our SOHCAHTOA, cosine of the angle is going to be the side adjacent to the angle divided by the hypotenuse. So the side that's adjacent to that angle, meaning next to it, is B. And then we divide that by that hypotenuse side, C. So it's B over C. And then tangent of the angle, is going to be the opposite side divided by the adjacent side. So the opposite side has length A and the adjacent side has length B. So it's just going to be A over B. Okay, so if you know the lengths of the three sides of a triangle and you are given this random angle theta that you don't know what it is, you can still find sine, cosine and tangent of that angle by literally just doing each of these sides divided by each other. So as long as you remember this mnemonic here, our SOHCAHTOA, SOHCAHTOA, as long as you remember that, then you can go ahead and find sine, cosine and tangent of the angle. You can also go ahead and find the reciprocals of each of these. Sine, cosine and tangent have reciprocals, and I want to go ahead and look at those. The first one is cosecant of theta. Cosecant is just the reciprocal of sine of the angle. So in our case here, to find cosecant of the angle, it's just the reciprocal of the fraction A over C. It will be C over A. So cosecant is the reciprocal of sine. Secant, again SEC, of an angle theta is just the reciprocal of cosine. So in our case here, that would be C over B. So secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So it's 1 over tan theta, which is just going to be B over A. So we have our three main trig functions, sine, cosine and tangent, and each one of those has a reciprocal, being cosecant, secant and cotangent respectively. Let's go ahead and do an example. Okay. We're going to find all 6 trig functions of the following triangle. Okay, so we're going to look at this triangle and find all 6 trig functions of the angle theta. So I have a right triangle here. I've got an angle theta down here in the bottom corner. And then the side that is opposite theta is going to have length 7. I'm not going to know x at the moment. I don't know what that side is that is adjacent to theta. And I know that the hypotenuse has length 16. And I've got to find sine, cosine, tangent, cosecant, secant, and cotangent of that angle theta. First thing we need to do is to find x. Okay, we only know 2 out of our 3 sides. I know by using the Pythagorean theorem that 7 squared plus x squared should equal 16 squared. If you go ahead and manipulate that and square it out and then subtract 49 from both sides, you should end up with x squared is 207. And remember, x is a length, so it must be a positive square root of that value. If you want to, you can go ahead and write it as a decimal. I would write it at least 2 decimal places, but I do like it if you keep it as accurate as possible. So if you want to leave the square root in, you can. That is totally fine, especially for these problems. It makes it look a lot neater and it's a lot easier to calculate this stuff. Then we're going to find our trig functions. So the first thing we have to look at is sine of theta, then cosine of theta, and then tan of theta. Okay, sine of theta, okay, going back to our SOHCAHTOA. Okay, sine of theta is opposite divided by hypotenuse. So the opposite side is 7 and the hypotenuse is 16. So it's going to be 7 over 16. Cosine of theta is adjacent divided by hypotenuse. Now we said that the adjacent side now has length square root of 207 or 14.39, whichever way you want to write it. And then the hypotenuse was 16. So that would be the square root of 207 over 16. And finally, tan of theta is going to be opposite divided by adjacent, which is going to be 7 over the square root of 207. You can rewrite that if you want to rationalise the denominator, but you don't have to and rewrite it like that, just because we tend to find it neater to put square roots in the numerator of a fraction rather than the denominator, but you do not need to do that. Then we need to find cosecant, which is the reciprocal of sine. So it's 1 divided by what we got for sine theta, which means it's the reciprocal of the fraction that we found. So it's 16 over 7. Secant of theta is just 1 over cosine of theta, so it's going to be the reciprocal of that fraction. And again, you can multiply top and bottom by the square root of 207 to rationalise the denominator. And then finally we have cotangent of theta, which is 1 over tan of theta, which we said tan of theta was 7 over the square root of 207, so taking the reciprocal of that and flipping the fraction would give us that. The next set of examples that I want to look at is where you are given one of the trig functions for this acute angle theta. So for some acute angle that's less than 90 degrees, you are given one of the trig functions for that angle. And what I want to do now is to find the other 5 trig functions for that angle when we just have that one trig function. We don't know anything about the triangle, anything else. We just have the value of one of the trig functions. So in these examples, we're going to be given one trig function of an acute angle. It's important that it's an acute angle. We will do examples in later videos where it's not an acute angle and you have to go ahead and do this, but right now we're sticking to an acute angle. So it's an angle that's less than 90 degrees. The reason that we do that, it means that that angle sits in quadrant 1. So we know that it's going to that terminal ray, if you were to draw out the angle like we did in our last chapter. If you go ahead and draw out that terminal ray, it's going to sit in that first quadrant. Okay, so given one trig function of an acute angle, we will find the value of the 5 other trig functions. Okay, I'm going to do 2 examples of this just so that you can see how we're going to proceed with these. So our first example, I'm going to say that secant of theta equals 7. I want to find the 5 other trig functions. Okay. Whenever you're given one of these reciprocal functions like secant or cosecant or cotangent, I would go ahead and write it back in terms of one of our 3 main ones, sine, cosine, and tangent. So what I would do here, but I know secant is 1 over cosine. Okay. So if that equals 7, okay, I know if secant is the reciprocal of cosine, then cosine is the reciprocal of secant, meaning that I can get cosine of theta by doing 1 divided by secant of theta, which tells me that cosine is 1 over 7. Okay, if secant is 7, that must mean by reciprocals that cosine is 1 over 7. Okay. My advice to you here is keep it as simple as possible. By that, I mean when we look at our SOHCAHTOA, okay, we said that cosine of the angle was adjacent divided by hypotenuse. Okay. So if I were to go ahead and draw a quick triangle here, I can now say, just to keep it as simple as possible, that my adjacent side has length 1 and my hypotenuse has length 7. So I've just set these equal to one another. You could make them more difficult and you could say that the adjacent side was 2 and the hypotenuse was 14 and start doing all this stuff where you do multiples. I would not do that. It makes it way too complicated. What I would do here is keep it as simple as possible because you don't want to mess this up mathematically. Okay, keep it as simple as possible. So I'm going to set my adjacent side as 1 and my hypotenuse as 7. Okay. In order to find my other trig functions, I need to know what this side here is. I need to know what the side opposite the angle is. That's where we come back to our Pythagorean theorem. And that tells us that x squared plus 1 squared equals 7 squared. So that tells me that x squared would be 49 minus 1, which is 48. And then I can just square root both sides. And again, take the positive square root. Now I can get all my other trig functions, okay? So I have already secant and cosine. I know secant is 7, I know cosine is 1 over 7. Now that I have the value of my opposite side, I can go ahead and find sine, tangent, and then their reciprocals. So we said that sine of theta was equal to the opposite side divided by the hypotenuse. We said the opposite was the square root of 48 and the hypotenuse was 7. Tangent of theta, tan theta, that was, when we looked at our SOHCAHTOA, that was opposite divided by adjacent. Our opposite side had length square root of 48 and our adjacent side had length 1. So that's just going to be the square root of 48. And now I can find their reciprocals. So cosecant of theta is the reciprocal of sine, which would be 7 over the square root of 48. Again, I can rationalise my denominator and multiply top and bottom by the square root of 48 if I wanted to. And finally, cotangent of theta is going to be the reciprocal of tangent of theta. And I can rationalise the denominator if I wanted to. For this example, our next one, we're given the fact that cotangent of theta equals 4. And again, I've got to find the value of all of the other trig functions. So I know that cotangent of theta is 4. I also know that theta is an acute angle, which, like I said, when we go through this later on, where theta is not necessarily an acute angle, then this will make more of a difference. But for right now, that's all we are concerned about. I can immediately, like we did with our last example, I can get the reciprocal function value out. So I know that cotangent of theta is 4. That tells me that tangent of theta must be the reciprocal of that, being 1 over 4. Drawing this on a triangle again, once you've got that. Okay, we know that tangent is opposite divided by adjacent. Okay, so if there's my right angle, there's my angle theta. The opposite side is going to have length 1. The adjacent side is going to have length 4. So if I go ahead and use Pythagoras, I know that the opposite side squared plus the adjacent side squared is equal to the hypotenuse squared. So that tells me that x squared is equal to 17. So x must be the positive square root of 17. So now I can go ahead and get sine and cosine, and I can get their reciprocals as well. So sine of theta, we said, was opposite divided by hypotenuse. So that's going to be 1 divided by the square root of 17, and I'm going to rationalise the denominator. And then cosine of theta was adjacent divided by hypotenuse. And again, rationalise the denominator if you want to. And then we know that cosecant of theta must be the reciprocal of sine, so that must be the square root of 17. And then secant of theta must be the reciprocal of cosine, which must be the square root of 17 over 4. So whenever you get one of these, you can immediately find the reciprocal function value for whatever you're given. Then you're going to draw out the triangle. Use the opposite, adjacent, and hypotenuse values as simply as you possibly can. So in this case, we knew that tan of theta was 1 over 4. So I set my opposite side as 1, my adjacent side as 4. Then I found my hypotenuse. Then I was able to find the rest of my trig function. So I would always go about these problems in that same way. The last thing that I'm going to go through in this video is looking at some angles that I want you to automatically know what the sine, cosine and tangent values of those particular angles are without dealing with triangles, calculators, etc. I will tell you now, you can always go ahead and do this on a calculator. With any kind of scientific or graphing calculator, it will have sine, cosine and tan on there. And as long as, for these problems, make sure you are in the correct mode. Your calculator will have a degree and radian mode. Make sure that if you are dealing with degrees, so if we're doing anything to do with triangles, make sure it is in degree mode. If we're doing anything else, we normally stick with radians. But for right now, if you're dealing with any of these problems, make sure that you are in degree mode. Okay. And then you can just do sine of that angle in degrees, cosine of that angle in degrees, and tan of that angle in degrees. Okay. And it will give you the value out of that. But some angles that I want you to automatically know what their trig values are. They are 30 degrees, 45 degrees, and 60 degrees. I want you to know the sine, cosine and tangent value of those, and then you can just take their reciprocals if you need to find out the cosecant, secant or cotangent values. Okay. The way that I'm going to do this is by drawing you two triangles that actually do exist. You can check them out if you want to. They'll be everywhere online, but they check out in terms of Pythagoras and with all of our sine, cosines and tangents if you want to check them on a calculator. But they are actually accurate triangles if you were to draw them out as well with a protractor and a ruler. Okay. This is one of the triangles. So if you had a triangle that had a right angle in it and the other two angles were 45-degree angles, okay, and it's such that each of the opposite and adjacent sides, so those two sides that are next to that right angle, they both have length 1. And the opposite one, that is the hypotenuse, the one that's opposite the right angle, that's going to have length square root of 2. Okay. Again, you could draw this out with a ruler and a protractor and it would check out. But from this, we can get sine, cosine and tangent of 45 degrees. So what do we get from this particular triangle? It tells us that sine of 45 degrees, okay, you could take either one of these 45-degree angles and you get the same thing. Sine is opposite divided by hypotenuse, which is 1 divided by the square root of 2. I will tell you now, in every situation, they will always rationalize this denominator for 45 degrees every time, okay? So what you have to do here is multiply top and bottom by the square root of 2. If you do that, you get the square root of 2 over 2. That is always how this is written whenever you see it in textbooks, etc. Sine of 45 degrees is the square root of 2 divided by 2. Okay. cosine of 45 degrees is the same thing. Okay, again, it would be the adjacent divided by the hypotenuse, and you can do that for either of those 45-degree angles. And you rationalize the denominator. So both sine of 45 degrees and cosine of 45 degrees have the same value. Tan of 45 degrees, remember that that is opposite divided by adjacent, is just 1. Okay, so whenever you do anything involving 45-degree angles, sine and cosine are the same thing. They're always the square root of 2 over 2. Okay, you can check that on a calculator if you want. Tan of 45 degrees is always equal to 1. The other triangle that you need to be aware of is the 30, 60, 90 triangle, which looks something like this. Okay, where we've got the right angle there, and that's the length of the sides, and this angle here is 60 degrees, and this angle here is 30 degrees. Again, the triangle checks out if you were to draw it out with a ruler and a protractor. But what we need to look at now, I'll first look at 30 degrees. So sine of 30 degrees, okay? I do opposite divided by hypotenuse. So the side opposite 30 degrees has length 1, divided by the hypotenuse has length 2. So sine of 30 degrees is 1/2. Cosine of 30 degrees is adjacent divided by hypotenuse, which is the square root of 3 divided by 2. And tan of 30 degrees is opposite divided by adjacent, which is 1 over the square root of 3, which again, normally they're going to rationalize the denominator. Multiply top and bottom by the square root of 3, so then that square root is on the top of the fraction to give you the square root of 3 over 3. And you can do the same with 60 degrees. So sine of 60 degrees. Okay, now it's the side that's opposite 60 degrees divided by the hypotenuse, which is going to be the square root of 3 over 2. Then cosine of 60 degrees is going to be the side adjacent to 60 degrees divided by the hypotenuse, which is 1/2. And tan of 60 degrees is going to be opposite divided by adjacent, which is the square root of 3 over 1, which is just the square root of 3. So sine and cosine of 30 degrees and 60 degrees, they actually have alternate answers. So sine of 30 degrees equals cosine of 60 degrees, and sine of 60 degrees equals cosine of 30 degrees. So make sure that you get those the right way around, because you are expected to know those values. And then tan of 30 degrees is the square root of 3 over 3, and tan of 60 degrees is just the square root of 3. If you ever needed the reciprocals of any of these functions, just remember you just flip the fractions. So, for example, cosecant of 30 degrees would be 2. Okay, it's just the reciprocal of sine of 30 degrees. Like I said, these are ones that you are expected to know. You will also be expected to know sine, cosine, and tangent of 0 and 90 degrees and 180 degrees, 360, etc. We will go through those later on as well, but for right now, we're just looking at acute angles that you find in a triangle. Any other angle, like I said, you can use a calculator. Just make sure that, particularly for this chapter, when we're looking at triangles, that you are in the correct mode. So make sure that your calculator is in degree mode and not radian mode, otherwise you will get the wrong answer. But you can always type these into a calculator, and especially if you end up with triangles that have odd angles in them that aren't 30 degrees, 45 degrees, or 60 degrees, then it is very useful to use a calculator, because it's not, unless you can draw out the triangle accurately, you're not going to find the answer. So whenever you get one of these problems, I would highly recommend to use a calculator. Or if you go back, you can always find sine, cosine, and tangent of an angle if you know one of the other trig functions like we did in these examples here.